Hello guys, welcome you all to the class. In this video, we are going to see some of the examples that how to find the HCF using Euclid's divisions algorithm. So here two numbers are given. We have to find HCF of them. Numbers are 4052 and 12,576. So at first, we have to check which one of these is greater one. So clearly 12,000 is greater than 4,000. Now we applied Euclid's division lemma. The greater one will be assigned as A. The smaller one will be assigned as B. We will divide A with B. This is our quotient. This is our remainder. So now, since the remainder is not equal to 0, we will assign this value as new A and this value as new B. Again, A will be divided with B. We will continue the process until we get remainder as 0. Okay, so let's see. Here the remainder is 272. Again, not 0. So we'll proceed further. We consider the new divisor 420 and the new remainder. Yeah, fine. 272. Apply the division lemma to get this. Remainder is 148. Again, we'll proceed further. This is new divisor, new remainder. Okay. So proceeding further, remainder is 24. 4 here. So after dividing 24 by 4, after dividing 24 by 4, we got remainder as 0. Remainder is equal to 0. So here we will stop and consider this value as our HCF, which is given in the second slide. So moving on. Since the remainder is now 0 and the divisor is 4, the HCF of 12,576 and 4,052 is 4. So that's how we'll get the answer. This is our answer. Okay. So here's another example. We have to show that every even positive integer is of the form 2q and odd positive integer is of the form 2q plus 1, where q is some integer. Okay. So now we all know that what is even integer? Even integer is integer which is divisible by 2, or we can say that it will end with unit places. Okay. It will end with having these numbers on its units place. Every even integer will have these numbers on its units place. So digits are 0, 2, 4, 6, and 8. So every integer which have 0, 2, 4, 6, and 8 on its unit place will be considered as a even number. Fine, even integer. And what's odd integer? All other whole numbers except this are odd integer. Okay. So yeah, further moving on. We have to question is we have to prove that Every integer number is of the form 2q and every odd integer is of the form 2q plus 1. Okay. So going with the Euclid's algorithm, we considered a as any positive integer. Let's consider a as any positive integer and b, this b is equal to 2. Okay, this b is equal to 2. Then we'll apply Euclid's algorithm. Apply Euclid's algorithm, we'll get when a is divided by b, that implies that a is divided by 2. Let guess like there will be some q and there will be some r, so we can write it as a will be equal to 2q plus r. These q and r are unique. Okay, for some integer q where q will be greater than 0. Now what about r? We know that, okay, we know that r will be greater than equal to 0 and less than equal to b, not equal to, less than b. Okay, since b is equal to 2, so we can say that r will be greater than equal to 0, less than 2. Okay, so what are the values r can get? R can get 0, 1, 2, but r should be less than 2, no? So it will not get 2. So there are only two possibilities of r to get. So we can transform this equation as case 1 and case 2. Okay, there will be two cases. In the first case, we will consider r as 0. So a will be equal to 2q plus 0, that is, this implies that a will be equal to 2q. Okay, and in the second case, r will be equal to 1. So a equals to 2q plus r, that is 1. So this is given here. R can be equal to 0 or 1 because will be greater than equal to 0 and less than 2. So a will be equal to 2q or 2q plus 1. These are the two possibilities. These are the two possibilities. So moving on, we'll see if a is of the form 2q, then a is an even integer. Okay, because it's obvious that 2q is divisible by 2. It's obvious that 2q is divisible by 2. Divisible by 2. Hence, if a will be equal to 2q, then a is an even integer. Okay, therefore any positive integer, odd positive integer will be two q plus 1. So hence we proved it using the Euclid's divisions algorithm. So that's it for the video. For this video, we'll meet with new example in the next video. Till then, bye bye.